All right, and then the next topic is static. So we're going to talk all about different static things. I'll go back to the examples that we looked at for problem, I guess, 1, 2, and 3 in the worksheet, code some out together. And then the last but not least, we're going to talk about just putting it all together and the practicality of this. Again, there's a lot of things going on at once. You've got all kinds of different information and concepts at your fingertips. So like, what is this used for? Where's our mind at moving forward in the design of this? We're going to start out with a little bit of vocabulary review. I gauged some confusion through there by reading your responses about a couple different kind of key ideas and the definitions, and certainly that can be confusing. I know there's all kinds of words that have new meaning and new context now, so we're going to start by doing that as we talk about all of this other stuff. So first, I'm going to go to Eclipse. Some of the vocabulary that I want to just go over is, first of all, this is a class, right? I've defined a class named book. When I define fields or attributes of this class, and I'm thinking in those UML diagrams, all of those things listed up at the top, we define attributes or things we want to store about the class. So the word attributes or fields, those are referring to items that belong to a book, right? Things that you want, you can think of information that you want to store about whatever this class is. So remember with dog, I think that was the very first class we ever designed together, we said all dogs had a name, all dogs had a weight, all dogs had a breed, things like that. So we're going to say that every single book is going to have an ISBN number. That's going to just be, you can think of it like an ID number, but that's kind of the title for books, but a unique identifier. And then all books are going to have a title, and we could go forward and say author and things like that, but I'm going to just keep this super simple. Every book has an ISBN number and a title. Good? Okay, so that's the idea of an attribute or field. These are things that belong to a book, and you can think of all of the books maybe on a bookshelf. They're all going to have both of these fields. They all have an ISBN number, they all have a title, but the values in those fields are different, right? The actual values are different. So I'm going to create these, private int, I'll call it ISBN, and then a private string title. Okay, the next thing I want to talk about is the word private. So private is an access modifier. So far, we've learned 2 access modifiers. We've learned private and public, right? The main difference being that private is only accessible within this class, and public you can access directly outside of that class. So usually we make all of our attributes and fields private, and then we make all of our methods defined down here public. And you've seen that on the UML diagrams annotated with the minus sign for private and the plus sign for public. Okay, so now I've got these declared. These are non-static. You can see I didn't put the word static in here. So by making these non-static, again, just in this context, it means that the values for these attributes will be different for each object. So non-static variables like these, the values are going to be different for each object. Now, let me show you an example so we can make sure we understand. I'm going to come over to a tester file, and I'm going to create a new book. I'm going to call it, let's see, what kind of book should I create? I'm going to call it Harry Potter 1 equals new book. Now, I don't have a constructor or anything made yet, but once I have those getters and setters or a constructor made where I can access items for this book, I want to eventually set its title to be Harry Potter and whatever the title is. I don't memorize those off the top of my head. And then its ISBN number is going to be something, And I don't know exactly what that is, but it has a unique ISBN number, right? And then if you think about creating another book, like here's book, I'm going to create Utopia. Totally different genre, right? But it's also a book. It also has a title, right? Its title is going to be Utopia. And it also has an ISBN number. I don't know what it is, but I do know that it's going to be different. It's unique, so it's going to be different than this book. You can imagine a library creating a new book. So creating, let's say, 100 more books. It's a very small library, only has 100. But each one is going to have a different value for the title and a different value for the ISBN number, right? So that's the idea here. Kind of taking this, going back to our definition, non-static means that the values, one had Harry Potter in this, one had Utopia in this, right? The values are going to be different for each object that I create. Good. A static variable is the opposite idea here. So a static variable, the value is the same across all objects. Okay, so in the examples that we've done so far, we've used static kind of like a counter, right? So I could have another variable, private static int, and this int I'm going to call next available ISBN. Maybe if I have no books in the world, I started at 0, but it's probably going to start at something big like 1, 2, 3, 4, 5, 6, 7, 8. I don't know, but the next available ISBN number. Then every time I create a book, I can increment this number by 1, and whether Harry Potter or Utopia went and looked at this number, it should be the same. So this is something in memory that exists one time, and it's created one time for the book class. So what I'd like to do now is I'd like to just take a second to draw this out in memory. So I'm going to set up where you can see me draw. When I create a new book, what that does is it goes and it gets enough space. So when I create a new book, like in line 8 here, it goes and creates a new space in memory. So there's something in memory. It's called, see if I can write here. We've named it Harry Potter 1. It's type book, right? And so we know that what this actually does is it stores a memory address. So I don't know what that memory address looks like, but I could print it out, and it stores a memory address pointing to somewhere in memory where there's enough space to store a book, right? I'm just kind of annotating this. There's enough space to store a book, and books require us to store any of those fields in here that are defined in the book class. So if we look at our book class, we need enough space for one int and one string, right? So if I pull this back up, a book needs enough space for an int, right? And it's called ISBN. And then it needs enough space for a string, and it's called title. Now, when I actually put values in here, I'm going to put a value in here, and I can't really type it all out, but I'm going to put Harry Potter. Oops, that's actually the int spot. So in ISBN number, I'm going to put an ISBN number, whatever it is. I'm putting 555 in here. And then for title, I get to actually put the title of the book, and I'm not going to write all that out, but it's going to be something of type string, right? Then when I create a second book, like in this line over here, see if I can share the page here. When I create a second book, like Utopia, this word Utopia, or this variable name, Utopia, points to somewhere in memory. If you make it where you can see the screen a little bit more, points to somewhere in memory where I have all of this information again. I have enough space to store another whole book object, right? And this book object, again, has enough space for an int, which is an ISBN number, and it also has enough space to store a string, which is the title, right? So ISBN number, maybe this one has 777, and maybe the title obviously is Utopia, and I can't fit it writing out right here. So I want you to imagine if I had created 100 more books, there are 100 more spaces in memory, and I'm kind of drawing these out, imagining each one of these is a different book object, right? 100 more of them, and each one of them has enough space inside to store that title and that ISBN number. Following me? So every single time I create a new book, I'm creating another space in memory. Think about in your actual computer, there is another space carved out to store this int and another space carved out to store a string. So if I had 100 book objects, I would have enough space to store 100 ints and enough space to store 100 strings. With me? Now, these static variables, so note all of these were non-static, right? The static variable we've said belongs to the class. So what happens is the very first time I create a book, we've got the book class was instantiated. So somewhere, and I'm going to kind of make this a different color here, somewhere I have something that is big enough to store an int, right? And it's called next available ISBN number. I'm not going to write that whole thing out, but it's just big enough to store an int. And at the very first time, it's going to have whatever this number is in it. So I'm going to put 1, 2, 3, 4, 5, 6, 7, 8, right? Now this is not created inside of here. So it does not belong to the object. If you see me drawing this in red in here, this would show that every time I create a new book, I create a new space to store this int next available ISBN number. That is not the case. So I'm going to remove that from here. It is stored a total of 1 time. Let me just get where I can write here. It's stored 1 time and 1 time only. And so if somebody updates it, they're updating this one space. I want to, again, point back out that all of these non-static instance variables, they belong to the objects. So every single book is going to have its own space for those to be stored, right? And you can see then that I can put different values in. I've got Harry Potter up here. I've got Utopia down here, right? Whereas this variable is static, meaning it belongs to the class. There is one unified space. All book objects can peek at it and look at it. I know that doesn't show well in memory, but there's only one space where it's defined. It does not exist in each new object or instance of the book class. So hopefully that clears up a little bit about how that works in memory. Okay, and to come back over here, when I create a constructor, so that's one of our vocab terms that at least one of you had asked me to clarify. All this is a special method, so it needs to be public, and it needs to follow all of the rules of normally creating a method, except it does not have a return type. So where we typically put void or string or whatever type the method returned, we leave it blank. And we need to name it the same thing as the class. So this is an example of a default constructor. Here's a default constructor, default meaning that there is nothing in the parentheses here. There are no parameters accepted. And this is a good way to, when someone creates a book, they call this default constructor like this, and we want to give these initial values. So maybe every time they create a new book, I want the next available ISBN number to increment. Before it increments, I want to assign the next ISBN number, the next available ISBN number, as the ISBN number of that book object. So the ISBN number equals the next available ISBN number, and then I increment it, right? So what this looks like is, for this first book that was created, Harry Potter, it calls this method, and the next available ISBN number is this one that ends in 8. It's going to get the ISBN number, so going into its memory, it gets the ISBN number of 1, 2, 3, 4, 5, 6, 7, 8, and then it updates the next available ISBN number to be 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So that the next book that gets called, and let's actually see if I can show this in memory real quick. So over here, just kind of drawing that out in memory, when Harry Potter is created, I'm going to erase the things that we put in here just for testing because we don't need ISBN numbers in here quite yet. Here's my box. When Harry Potter is created in memory, I'm going to assign whatever the value is in next available ISBN number, this value right here, into its attribute ISBN number. So over here, I'm going to copy over this value, 1, 2, 3, 4, 5, 6, 7, 8. The important thing here is that it ends in the 8. Then I'm going to increment this next available ISBN number. So you're going to see me, I'm going to erase this 8, increment it to 9. And when the next book is created, right here, Utopia, Utopia, again, is going to call this default constructor. It's going to get the next available ISBN number. That's this. It ends in a 9. So you'll see me copy this over right here. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then increment this next available ISBN number by 1, which we know would make this 6, 8, 0. 7, 9, incremented by 1 is 80, and so on and so forth, right? So we're going to continue in this fashion, and hopefully you can see that this is only updating in one place, but this received the value. It's still 1, 2, 3, 4, 5, 6, 7, 8. This is still 1, 2, 3, 4, 5, 6, 7, 8, 9. And so this is one instance of how to use these static variables to generate unique numbers. This is a very common use case for static variables, but it's certainly not the only use case. All right, so keeping this example in mind and the way that static variables versus non-static variables are stored in memory, let's look at one more use case of when you might want to use a static variable that's not just a counter for something. So I'm going to create a new note here. Let's see if you can see it. Yes. So here I'm going to create a new dog class. I'm imagining the dog UML diagram here. And so first I want to list some of the attributes that all dogs are going to have. So I'm going to make it private. And let's say that all dogs have a name. We've done this before. All dogs are going to have a weight. And let's say that all dogs have a num legs, right? All dogs have a name, all dogs have a weight, and all dogs have a num legs. Now, with some exceptions to dogs who are maybe missing limbs, the variable num legs should have the same value for all dogs. We could name this something better, like the number of legs they should have, right? But all dogs have 4 legs. Again, this is assuming that we didn't have any amputations or things like that. So between these variables, num legs is a little bit different than the others. I'm going to make it italics because italicized in UML diagrams means static. When I store this in memory, let's see if I can draw this out. Every time I create a new instance of the dog class, let's imagine I'm creating my dog and your dog, right? I'm going to have 2 instances of the dog class. My dog should have its own space for its name. I'm going to create, I'm actually going to do my brother's dog, Duke. And then your dog, let's imagine his name is Rufus. Or you can imagine your own dog's name here, right? They each have a space for their name, and they should each have a space for their weight here. Maybe my dog is 50 pounds, maybe your dog is 20 pounds, right? So you can see that the values are different. However, if I had another space in here for num legs, in all likelihood, it's going to be 4 for both of them. So if I then kind of expand this idea to having 100 dogs, having 100 different spaces to just store that same number 4 becomes really inefficient. I don't need 100 different spaces in memory carved out to store the number 4. I can create one unified space. I'm going to change my color over here. Name num legs. It's got that number in it, and all dogs share this value. Right? Now I know this is kind of a silly example, but hopefully this can point out the difference to you of why you might want to use a static variable to save memory, even if it's not a counter variable. So I'm going to go back in here just for clarity and erase those different boxes. I did want that still filled out. And so again, hopefully that clears that up. Okay, so the next thing I'm going to do is I'm going to leave the dogs example because that was kind of silly, but it hopefully taught us something. Go back to my library class. And in this library class, I'm going to have as my one field, I have a hash map that maps integers to books. Integers being those ISBN numbers, and then mapping them to book objects. I'm going to call it book list or book map equals new hash map mapping integers to book objects. Now hopefully you're already familiar with hash maps from your earlier chapter 9. I'm going to import hash map, import java.util.hashmap. But this is a really good example of when to use a hash map. Because I want to store objects or books, again, imagine that each book object, Harry Potter, whatever it is, all this really is a memory address, right? If I just come show you really quick, I'm going to say system.out.println Harry Potter 1. You can see that it's going to be a memory address. Run it. And sometimes I have to go show my console. I have rainbow wheel. There we go. This is the memory address that is getting stored in, so it's a book and it's at this memory address. It's getting stored in whatever collection. Now, if this had been an array list or an array, that's totally fine, except storing memory addresses is kind of sloppy. There's no easy way to just pull out and retrieve a certain book you want. So it's much nicer to map these ugly addresses to something more meaningful, like an ISBN number. We could also have chosen to map it to the title. I would have put string here, but typically you want to use whatever's most unique. So this comes to a design decision. Neither one of these I would consider wrong. I would need to make it match and say string over here, but I'm going to do an ISBN number since I've designed that to be the most unique. Changing this to integer here. So now I want to just review wrapper classes really quick. Hopefully, and from what I gathered from you last week, you feel okay putting the wrapper class right here and knowing that you're really going to store ints. But I got a lot of questions about boxing or auto boxing and auto unboxing. So I'm going to just code some sample things over here. I'm going to get rid of my tester code. And I'm going to just look at auto boxing and unboxing. First of all, int x equals 5. If I just observe this line of code, x is a primitive type, right? Primitive type, meaning primitive type, meaning that in memory, x actually stores in enough memory the number 5. Whereas if I have a reference type like a book, b equals new book, this is just one of many examples of a reference type, b actually stores in memory an address. And we saw that right over here, right? B actually stores an address. So the main difference between a primitive and a reference type is what's actually stored in memory. Primitive types store actual values. You saw that over here. Primitive type like ISBN number actually stored the value or that number 1, 2, 3, 4, 5, 6, 7, 8. Whereas the reference type like a book stores an address to where that book is. This is the same thing with arrays, and we've largely talked about this with arrays and how reference types behave different than primitive types. So just to show you another really quick example, if I had this is another example of a primitive type versus a reference type. We know that y actually stores in memory an address to where 1, 2, 3 are stored, right? Good. So anytime I'm working with any type that is not one of these 8 primitive types, again, the 8 primitive types are all of those types beginning in a lowercase letter, and it's just the single instance of that type. So I can't be talking about an int array, just an int, a double, a long, a char, all of those beginning in lowercase letters. There's 8. If you are dealing with an object or a variable that is anything other than these 8 types, you're dealing with a reference type. Reference type. So we mainly looked at how reference types work, looking at arrays, but now I'm just asking that you expand your mind a little bit to, it's not just arrays. Everything we learned about arrays as far as what happens when you pass them in, what happens when you print them, it is exactly the same for any other reference type, any non-primitive type. So we're just going to scratch through the word array and say reference type. This is how all reference types work. So with that kept in mind, another and our final example of a reference type is something like this. Integer y equals 5. Now, this is not one of those 8 primitive types, so this is also a reference type. We know that these classes in Java, integer, double, character, these are called wrapper classes, right? And so this is a reference type, but it's also known as a wrapper class. And it's an actual class in Java, meaning there's an actual class, just like we have this public class library. There's a class somewhere that says public class integer. So it's an actual class in Java. You can look through the Java API for it, but what it does is it stores as its single variable an int. So I'm going to just kind of draw this out for us over here, see if I can pull this up. The integer class in Java stores as its single attribute something, I'm going to call it x, but we don't know what it is, and it's type int. So all it really is it's a way to store a single int, but it's wrapped in this package. That's why it's called a wrapper class. I imagine this just wrapping up an int in a little bow, right? This is my poor attempt at a bow. But all it is a single int stored in memory, but it's wrapped in this larger class. And because we've wrapped it in this larger class, why not go ahead and give it some useful methods, since we can do that with classes. There are methods in here. The most common one is toString, at least in our textbook and our scope, but there's all kinds of methods that exist in your different wrapper class. If we think about this being the character class, we'd already been using methods like is white space, to uppercase, all of those different things would be methods listed in the character class, not integer. Perfect. So then using these different methods, I can say something like integer.toString 5. And what that's going to do is it's going to return, if we were to read the documentation, the string representation of 5 or something that looks like this. So I could store it in a string. I can't name it x because I already have an x, but str equals integer.toString 5, and now it's got 5 in quotes. So that can be a useful thing, take a number, turn it into a string. But there's all kinds of methods in here. We don't really have time to go through them, but at this point, hopefully, you're getting more comfortable with using the API, seeing that it returns a string, so I can store it in a string, it accepts an int, so I need to pass an int in here, and just looking at examples and kind of following that template of how to call them. We also know that these methods must be static just by looking at this, because notice that I didn't have to call this with an integer object like y. I could have, because y is type integer, I could do that here, but we didn't have to create an integer object to call it if I didn't have this line of code, right? There's nothing else in here about the integer class, and we were able to call it using the name of the class. Also note that Eclipse made this italicized, which should be another little hint to you that it's static. Static methods can be used to access static variables, but they also exist so that we can use these as like helper methods when we don't want to instantiate the class. I don't want to create an integer to have to use it. We've been doing this all along with those character methods, so I can say things like character.isWhitespace. We've done this in all kinds of projects. It expects a char, so I'm going to put the char A in there. We know that's not white space, so it would return false. Right? But again, note that I called it with the name of the class. So now I know that this is a static method. And again, you can see it turn italicized in Eclipse. And this method returns a Boolean, so I could store it in some Boolean that I named something. Awesome. Now, auto boxing and auto unboxing. If I go back to this example, I'm going to remove these and go back to this example. Typically, when I have things of different types, like maybe I have a book and an int, I can't store a book and an int. I can't store an int in a book, right? Those types don't match. However, with wrapper classes, Java has made them mostly interchangeable. They're very proud of what they did, so they gave this interchangeability between wrapper classes and their corresponding primitive types definitions or names. So the vocabulary term is auto boxing and auto unboxing. Now, if you think about boxing being taking this int and wrapping it up in a box, right? It's that simple. I can say something like integer y equals, taking this line of code out, integer y equals x. Now, typically, this kind of statement, I want to note, is not allowed because x is an int. That's a primitive type. Integer is a wrapper type, or it's a reference type. I can't assign an int to a reference type. Normally, this kind of statement would cause all kinds of errors. But again, Java has made them very interchangeable, so I can store an int in an integer, and it auto boxes. It auto takes this int, wraps it up in this package for us. So this is an example of auto boxing. Without getting into the details of how it does it, because really, who needs to know that and who cares? This is the simplest definition of that. Auto unboxing is the opposite. I can do something like this. I'm going to say I have an int z equals y. Now again, y is a reference type. It's type integer. Z is type int, right? Typically, we're not able to assign things of different types, especially primitive reference types, to each other. But this is allowed. What this is going to do is it's going to take in memory enough space to store an int and put in it. It's going to extract from this wrapper class just the int. So it's going to auto kind of break apart this wrapper class or this box to get just that int out. And this is the idea of auto unboxing. Now, these are just, again, fancy terminologies. We've been doing stuff like this all along. We've been having array list or hash maps that stored integers, right? And putting ints in there, pulling them back out as ints in for each loops. We've been doing that all along. Now we're just adding some terminology and really just asked to observe that, hey, that's not typical. We're not normally allowed to do that. These are the terms for how Java coded this so that we could. Awesome. Hopefully that clears up wrapper types. The one other thing I want to point out is static versus constant. No one directly asked this question, but I did see maybe some uncertainty in some of your answers. Remember there were constants back in the day that we were working with? A constant was something that we declared as final. So I can have like a final int, final double pi equals 3.14. This is something that is never going to change. The keyword final is often confused with static because we think static means like not changing, right? That's not what it means. Static means it doesn't change for the objects of the class, right? Final, if I have something declared final, then I cannot change it. I can't come after that and say pi now equals 3.15. It's going to give me an error, and it's going to be, well, you said this wasn't going to change. So this is not, by definition, a variable. It cannot change values. If we go back to our example, I'm going to go back over here to where we had the book example with Harry Potter. This example, this was a static variable, but we saw that it did change. So we're allowed to change the values in it. It just exists once across all instances of the classes. So there is some confusion there that I think I saw where you guys were trying to create final variables. And certainly a variable could be both static and final. That means there's only one instance of it across all classes. And we don't want that number to change. That is possible, right? Maybe in the dog example, that's a good example of a static and a final. There's only one number across all dogs, and we don't want it to change, right? But with this example, we did want that value to be able to change. So just go back and review final. I think that was back in chapter 3. If you're, if we've forgotten it and moved on to other things since then.